So, example 1. Okay? We need to summarize these questions. The questions give you the object of synchronous generator, right? Synchronous generators. How many phase? 3 phase. Why we do 3 phase? Because Y connection. Okay? Y connection means 3 phase. Okay? Yeah. So if we have Y connection, we conclude directly VL is square root of 3 times V phase immediately. Okay? Right? Right? We have the frequencies FSH is 50 Hz. This is 3 phase. This is 3 phase. So please remember that the voltage here is always line voltage, you know. Line voltage. Again, this is 3 phase. This is 3 phase synchronous generator. So please remember the voltage here, the voltage given here is always line voltage. Okay. So if you say here is phase voltage. Okay. We fail this course. So here we have VL, so you can calculate directly with phase, right? With phase. How many? 4 80 over 0.3. Now, help me please. Can calculate that please. Okay, we get 2771. And we have 200 kVA. Okay, so this is kVA, so that means S3 phase, right? S3 phase is 200 kVA. Okay? Yes. They also let us know about the field current, rated field current. So we have IF rated. How many? IF rated is 5 amperes. 5 amperes. Okay? Yeah. So, questions. Question 1. Please calculate what? Oh no, this is not the question. Okay, they do the test. Okay, this one is open circuit test, right? Open circuit test. So if they do open circuit test, okay, they give us the information of VTLC. Remember, VT mean line voltage, right? Yeah, we discussed before. So this is VL open circuit. That's a how many? 540 volt. Okay. And it's what? Okay, and IF is 5 ampere, right? VTLC at the rated IF and the rated IF here 5 amperes. Okay, so if when we do open circuit test with IF a 5 ampere, you can get open circuit voltage is 540 volt. So after that, you can get V phase open circuit, right? V phase open circuit is EA rated, right? Yeah, we discussed before. So this one we have 540 divided by the root of 3. How many please? How many? 311. 12. Okay, round up. Okay, number 2. We do what? We do short circuit test. Short circuit test. We do short circuit test. Okay, so they give us the information of IL when we do short circuit, to get short circuit, current IL short circuit, how many? 300 ampere at IF to be 5 ampere, right? So because this is Y connection, so IL equal to II or I phase, right? Right? So here we can get IA. Sorry. We have I phase or IA is a short circuit. Short circuit is 300 amperes, right? Because we have Y connection. Number 3, when a DC voltage of 10 volt was applied to 2 or more of the terminals, a current of 25 amperes. This is Y connection. Okay. So this is stator. This is stator, right? This is phase A, phase B is phase C, right? Alright. And we have what? We have resistor. This is JXS RA. Similar. JXS RA. This is phase A, phase B, phase C. This is stator, right? And we have rotor over there. So they supply DC voltage, right? DC voltage. How many volt? 10 volt. Okay? Because this is DC, so we don't care about JXS. Right? Do you know why? Because X is omega L. Omega means 2 by FL. This is DC, so F is 0. So we don't have X. Right? So this is RA. So if we apply beta 2, you can get 2 RA is 10 over what? We need IDC. IDC how many? I hope we have the information. Oh, we are very lucky here. 25 amperes, right? So here if we have M meters, yes, here we have voltmeters, you can get IDC. So it's the way we measure I, armature resistance, right? So we have 10 volt over 25 amperes. So we can get I, how many? 0.2 ohms. Yes. So here, with conclusion, we get conclusion RA is 2.5 ohm. So, questions? Any questions? Find the values of the armature resistance and the approximate synchronous reactance in blah 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 blah. Okay, yeah. So the key word is here. And the rated condition. Every information here is rated. Rated IF. Okay, yeah, rated voltage. Okay, so they require to calculate RA and XS. We already get I. Okay. Yes. Now we double check. Yes. Okay. Yeah. Correct. Okay. Correct. Now, how can we calculate XS? So we know that S is RA plus JXS, right? And then we can get absolute value. That S is square root of RA square plus SS square equal to what? Equal to D I here. Okay, EA short circuit over IA rated, right? Right. Or equal to we face open circuit divided by IA short circuit. IA short circuit. So look at this one. Look at this one. They give us the information of we face open circuit. Of course, we know V line, so we can calculate we face open circuit. They also give us IA short circuit. Okay? So what's the experience? The experience is how to understand fully the question, how to summarize correctly the information from the questions. Okay? So here you can get how many? You can get how many? 3 12. 3 and 12 divided by 300. This is ZS. How many please? 1.02 ohms. Okay. So after that we can calculate what? Calculate XS, right? SS is the square root of ZS square, that means 1.02 square minus I how many? 0.2 square. And then we can get the answers. XS is 1.02 also. Please double check. Is this correct? I don't know. We need to calculate. Maybe 1.01. I don't know. How many? 1.00. That's all. That's all. Maybe because we round up, right? We round up. We face open circuit here. We face open circuit in 311.8. We use 312. So maybe it's a little different. Okay. So if we skip I, so XS is approximately equal to ZS, and you can get 1.02 ohm immediately. Okay, it depends. But now we cannot skip, right? Because the question requires us to calculate I. Okay, that's all. Finish. Ồ, vậy đó thằng nấu nữa hả? Ồ, hay nha. Okay, so any questions? And of course, you need to understand the equivalent circuit. Okay, so when you get I and XS, okay, you can draw equivalent circuit. Equivalent circuit. Okay. Yeah. So RA is 0.2, XSA J1.02, this AI phase, and EA how many? EA 310, and the phase angle, this is delta. We don't know delta. We don't know delta because no information about that. Okay? So Okay, now 2.8. 2.8. We discussed about the synchronous generator operating alone. That means we have one generator, one load. This is a very simple system, right? Very simple system. One generator, one load. Yeah. And then we need to consider the phasor diagrams for different kinds of loads. We have three kinds of loads, right? Yeah. So figure A, this one is lagging power load. Sorry, lagging power factor. How can we know? Because IA lags V phase. Okay, this is IA and V phase are in the same direction. So this is unity power factor, or power factor is 1, and this is leading power factor because IC is leading V phase. So, we have the formula of internal generated voltage. We have EA. We have EA, E proportional to K phi m omega. Phi m means rotating magnetic field. Okay? Yeah. So, and then we have lagging power factors. We assume this RA is 0. We assume this RA is 0. Yeah, RA is 0. So, we can have the phasor diagram. This is V phase. Lagging, so here is IA, this is theta. Okay, and then we ignore IA, so we have we just have XS, J's, XS, IA, and this one is EA. Okay. Yeah. And of course this one is delta. And this one is EA is constant. So EA is constant if, right? AI is constant if phi m and omega are constant, right? Yeah. So when we fix the rotor speed, that means omega is constant. So if IF is constant, IF is constant, phi m is constant. Okay? Yeah. We assume AI is constant because phi m and omega are constant. Okay? Yeah. Now we increase log. So for lagging, we have EA is V phi plus J's XSIA because RA is 0, right? Yeah. So if we increase V phase to be V phase over common, we increase. Okay, we increase V phase to be V phase over common, like this. Like this. Increase or decrease? Decrease. Decrease. Okay, decrease. So there's maybe I'm stupid. Okay, again. We increase what? We increase log. We increase the load current. Okay, we increase the load current IA. IA. At the beginning IA here, we increase the magnitude of IA to become IA over common, right? Yeah. So AA is constant, right? AA is constant. And IA is increased because we increase load. So this one should be used. Okay? Do you repeat me? Because AA constant. So we conclude that V phase over common less than V phase. Okay, so now we have EA over common. EA over common. Because we increase IA to become IA over common. Okay, so the magnitude is bigger. Yeah. And this is the origin, and the magnitude of EA is constant. So this one like the circle. This is the circle, right? This is the circle. So EA now, the magnitude of EA become the radius of this circle, right? Right. And V phase E, V phase E, V phase E decrease. So now this one becomes, maybe, now we have EA over common like this. Okay, and this one should be in perpendicular to this one, right? So here is V phase over common. V phase. Okay, this is similar to the view. When we increase IA over common, V phase decrease to V phase over common. And EA and EA over common have the same value because it's actually constant. You get it. You get this one. Okay? So if we continue to increase IA, so now you get IA double over common. You get EA double over common somewhere here. Okay? Yeah. And then this is V phase triple over common. Okay? We increase more and more IA, that means we decrease more and more V phase. Okay? You understand? Yeah. And similarly, we have unity. Unity like this. Okay? Like this. We discuss now lead-in part of it. So for lead-in power factors. Okay? So, do you remember for leading power factors, EA magnitude less than what? Less than V5. We discussed before, right? Right? Yes? So, that means we have to put this equation like this. So now EA is V5 minus JXS IN. We assume RA is 0. Do you agree with me? We discussed this one before, We have the comparison table for 3 cases. Leading power factors, unity power factors, and leading power factors. So, I hope all of you remember this one. Okay? Now, we draw. So, when we increase IH, and EH is also constant because we keep what? We keep rotor magnetic field and rotor speed. So if this one increase, V phase also increase because EH is constant. You understand? Yes, okay. So here we have V phase. So IA now here, IA here. Why? Because leading. So IA least V phase. And then we have what? We have JXSIA. Okay. So if you move it to the left, you can get V phase EA plus JXSIA, right? Okay, so particular, so here is JXSIA. And this one is EA. Yeah. Okay? And because EA is constant, so you get the circle. Yes. And this is radius. Do you agree with me? Yeah. So now, when we increase IA to become IA over common, IA over common, okay? EA is also constant, right? EA is also constant here, okay? So for I assume EA over common here, because EA is constant. Right? So we can guess what? Right? Positive. Sorry, it's the perpendicular. That's it. So now this is V phase over common. Okay? Coincide. It is coincide. The theory. When we increase IA, V phase increase to become V phase over common. Okay? That's all. Okay, so it depends on different kinds of plots. We have the corresponding phase error. Any questions? And of course, for unity power factors, this is for yourself. Try to understand for yourself. Okay? Conclusion. So if we have a lacking lot, that means we get positive reactive power. Okay. Why? Because we find degrees. Okay. So for unity power factors, reactive power is 0. For lived-in lot, we find is enriched. So that means reactive power is negative. Okay. Yeah, of course we understand voltage regulation, right? Voltage regulation is no loss voltage minus full loss voltage over full loss voltage. Okay, summary. 1, 2, 3, 4. 4 minutes. Try to understand this summary. Okay. You must understand. If you don't understand, you cannot answer the homeworks. Right? When we decrease field resistance, right? We decrease field resistance, that means we increase field current because DC voltage is constant. So when we increase IF, that means we increase rotor magnetic flux, right? We increase rotor magnetic flux, that means we increase EI, right? Look, an increase in flux, increase the internal phase voltage EI. So if EI increase, and IA is a constant, we phase increase. Okay? Yeah. So we have two ways. The first way, we consider EI to be constant, and then we increase loss current. Okay? The other way, we keep IA to be constant. We increase AI by increasing phi m, and we phase increase. Okay? Yes. Example. You have 5 minutes. Try to summarize these questions. And one student come here to give a summary. Okay? Who volunteers? And, okay? Maybe we have one girl and one boy come here, and then we get the comparison between male and female students. Who is better than the others? Okay? Okay, so now one okay. This is a girl. This is a boy. Xuân Quân. Okay, and you. Okay, come on, 5 minutes. And you need to summarize the picture for yourself. Okay? Come on, quickly. Oh my God. Maybe here. Okay. Come on, come on. We don't have more time. Quickly. One, quickly.加油 Come on. Fighting, fighting. Remember that I am asking you to summarize, not give some words and write the numbers. This is not summary. Okay? Nói gì? Khổ gì vậy? Lộn cái gì hả?